This video will go through some of the things that you can do in Excel for creating a probability distribution and then finding its mean, variance, and standard deviation, and then also a little bit about how to use the binom range formula for binomial distributions. So let's start with creating a probability distribution. The first thing that you have to do is have some possible probabilities. So you're going to need a column for your x's and the probability of each of those x's. So basically a sample space, a list of all the possible outcomes. So one of the examples we did in the notes, but just for the purpose of our example here, has values like x could be 1, 2, 3, or 4. Maybe they're like slips of paper with those numbers on them, and those are the possible numbers that you can pull. And then the P of X would be the probability of each of those things happening. So it's your sample space with each of their probabilities. So say maybe there's one slip of paper that has a 1, and two that have a 2, and three that have a 3, and four that have a 4. So that would make the probabilities 1 out of 10, 2 out of 10, 3 out of 10, and 4 out of 10. Because if you count up all those numbers together, there's 10 slips of paper. One thing I want to point out here is at first, if you try to do something like a fraction, like 1/10, it's going to probably guess that you're doing a date. Okay, so if you want it to be a fraction, what you're going to want to do is highlight any of the columns where you think you might be using fractions, and you can do even more than what I just did here. And when you go to your Home tab, where it says Custom here, there's kind of a cell formatting area. You don't want it to do custom because then it's going to guess. You want to either choose number and it'll do decimals, or you want to choose fractions so that it'll show as fractions. So let me show you fractions. If you change that to fractions and then you put in something like 1 out of 10, it should stay a fraction. It gets a little funny um, when you first had a date in there. You can see on my formula bar here, it is having the correct answer as decimal 0.1, but it's kind of rounding it. So it's correct in there. And you can see I put in 2 out of 10 for this one, but it reduced it to 1 out of 5. That's fine as well. So even though it had some zeros, it's actually accurate. It's just more of a display thing. I recommend maybe using the number feature instead, where you're going to have some decimals in here. So I'm going to use number. Okay, so then when you put in something like 1 out of 10, it'll just put it in as its decimal form. So you can still type it in like a fraction, but it'll convert it to the decimals for you. Okay, so we're going to use the decimal format here. All right, moving on into what we have to do to go further than this. So this is a probability distribution, and we know this because each of the probabilities are between 0 and 1. And if we just do a quick totals row down at the bottom here, and we go into our formulas tab, you can just use this auto sum. There's that sigma symbol that means sum, and sum up this column. If it doesn't guess correctly, just click and drag across the right numbers here, and we want to make sure it totals up to exactly 1. If your total is not exactly 1, then double check the probabilities that you put in. Probably something is off there, so you need that to total up to 1. All right, now to find the mean and variance and standard deviation, we have to create 2 more columns. The same thing we would do if we did it by hand. We're going to need an x times the p of x column. And I'm just typing a label for this. I'm not actually doing any of the math yet. And then I'm going to need an x squared, so x to the second power, times p of x column. Okay, again, just a label up there, but the label actually gives you a reminder of the keys you're going to hit to do the calculations. So for the x times p of x column, remember when you want Excel to be a calculator, we're going to start with an equal sign. And you can type the numbers, but I highly recommend clicking the numbers because there's a cool shortcut if you do this. You're going to click the x in that row, and then the asterisk for times, and click the p of x next to it. So each x times its own p of x. And when you hit enter, it'll actually do the calculation for you. And you can continue doing that. You could do the same thing for each one here, equals x times its p of x, and do that all the way down the line. But if you want a little shortcut, let me get rid of that one real quick. Once you do even just the first one, normally your cursor is this fat white cross. If you hold it over this little extra green square in the bottom right-hand corner of the cell, turns into this skinny black cross. You're going to click and drag it down, and it will repeat that calculation for you on the other rows. So if I click on this here and you look at your formula bar, you can see it's doing this one times this one. And when you go down, it's doing the next one times the next one, etc. And we can do the same thing for this column here. So the difference is we're going to square the x's. So we start with our equal sign. We're going to click on the x, but then we're going to do this caret. It's above the number 6 key on your keyboard, 2. So it'll be like that x to the second power times, again, the asterisk, its own p of x. So we're clicking on the same two boxes here, but in the middle we're doing that squared. And let me show you one more time. Equals x to the power of 2 times its own p of x. And again, you only really have to do it once though, because you can use this shortcut. And once you do one of them, get that little corner in the bottom, make sure it turns into that skinny black cross and drag it down. And then you can also drag across the totals or just auto sum these as well. But it works if you drag across the same way from the shortcut. Okay, so we have all our totals here. So we're just creating that probability distribution, the same thing we would do by hand with a calculator. Now, the next step is if we want to find things like the mean and variance and standard deviation for a probability distribution, you can do that. The key is you are not going to use the built-in formulas for these. You're not going to use the built-in average for the mean or the var or the standard deviation functions. Those will not work correctly. It's different than when you have a set of data that you're working with, a set of sample data. This probability distribution means all the things that could happen. And so the formulas aren't quite the same process to get them. Now, if you remember though, the formula for getting the mean was simply just to multiply each x times its own p and then add those together. So since we actually already did that calculation, we did each x times its own p and we added those together. This third column total, the 3 in this case, is the mean already done. So I can just copy and paste that over here or just type the mean. Oh, it doesn't like that. We'll just put the 3 in there, no problem. Okay, and then for the variance, it's the x squared times p of x's totaled together. So we need this 10, but we're not done there. It's not just the 10. It's that number minus the mean squared. So we're going to make Excel be the calculator here again. We're going to start with an equal sign. What you're going to do is click on that last total minus the previous total, but square it. So just like we did with the square here, you do caret 2. Okay, let me do that one more time. It's the total of the last column minus the previous column, so the mean, but squared. Okay, so our variance comes out to be 1 here. And the standard deviation is always just the square root of the variance. There's not a square root button on your keyboard, so you're going to click on Insert Function. And you're going to type SQRT. It's square root without any of the vowels, SQRT. And you just hit OK on that one. And you're just going to click on the one number you want to take the square root of. Standard deviation is always the square root of the variance. So you just click on the variance here and it'll take the square root for you. Now this one is a nice easy example where the standard deviation happened to be 1 as well because the square root of 1 is 1. Generally standard deviation is going to be not a nice even number like that, and you'll probably have to round it off a little bit. I will go over rounding in the next section again, but that is the main part for creating a probability distribution and then finding the mean, variance, and standard deviation. By the way, this process that we just did here and what I'm going to show you with the binomial questions can be done either in the web version of Excel or in the desktop version. They both have the same features here and can do it either way. So it doesn't matter which version you are in. Okay, so the second thing I'd like to go over with you guys is how to use the binomial formula. So we did some examples in the notes. I'm going to repeat them here. And I'll show them on the screen too, in case you're not familiar with them. We did an example with a sharpshooter, and then we did an example rolling a pair of dice, and we did an example with finding defective products. So let's look at each of those 3 examples here with the binomial formula. Totally separate process than what we just did, by the way. but I'm just combining it in this video here. So this is for working with specifically probability distributions that are binomial distributions. So for something to be binomial, it's a repeated experiment. The things that happen on each trial don't affect the probabilities on the next trial. It's the same probability of success each time, and that does not change along the way. Those trials are independent. And there's only two possible scenarios, either the probability of what you're looking for or the probability of anything but that. And they are exact opposites of each other. So they always add up to one. So in this particular example, we thought about like what it is that we're trying to find the probability of, just in general. We're trying to have the shooter hit the target. So our success was hitting the target. So this little p stands for the probability of doing so. So probability of hitting the target, according to the problem, was 70%. Little q is the exact opposite of that. So if she hits the target 70% of the time, the probability that she does not hit the target would be the other 30% of the time. So as decimals, that's 0.7 and 0.3. Together, P and Q add up to 1. So if you ever need Q and you're not sure what it is, subtract the P value from 1. Now, the nice part about Excel is you actually only need the P for it. You don't actually even need the Q anyway. The other two numbers that you will need is what they call the number of trials. We call that our N value because it relates to sample size. In other words, how many times are you doing the experiment overall? So in this case, 8 times, 8 shots. And then X here, which is different from X from the probability distribution, so don't be confused by that. Just means the number of successes. So like how many times exactly do you want to do this success? How many times do we want to hit the target? Exactly 6. So our X value would be 6. So we're going to use, I have this towards the end of the slides here. We're going to use this BINOM.DIST.RANGE function in Excel. So we're going to search for that function. It's going to ask us for 4 different things here. The first box it's going to ask us for is the trials. In that box, we're going to put the N value. In the next box, it's going to ask us for the probability S, which stands for the probability of success and what we call the P value. And then it's going to ask you for the number S, and that's the amount of successes. So that's what we call our X value. Try not to confuse these with each other. N is a whole number. It's your overall number of trials, and that's going to be your biggest number. P for probability has to be a probability. So it has to be a value between 0 and 1 as a fraction or a decimal. No percents. In this case, if it's a percent, change it into a decimal. And then X is going to be a whole number again. So it's not that fraction or decimal like P is. So try to keep those straight. Now there's one other box that you can fill in, and that's only needed if you're doing more than one X value. So sometimes in the problems you'll see in the dice example and in the defective product example, we want to look at the probability of more than one success, not just 6 times hitting the target, for example. If we wanted to hit the target 6 to 8 times, then we would use this second box as well. We would put in the first X value, so 6, and then the stopping X value, 8, would go in the second box. All right, so let's actually calculate the answer to our shooter question. Let me go back to the question here again. We know again our first thing it's going to ask us for is trials, and that's 8 because we're taking 8 shots. And then they want the probability of success, so that's little p. So we're going to put the 70%, but as a decimal. And then the exact number of times we want that success is 6, and we're going to put that in the third box. And since it's only that one X value, we only have to use that first box, not the second one. So here's what it looks like over here in Excel. There's really nothing you have to type into Excel unless you want for yourself like a list of the values over here. You just can go straight to the formula. So we're going to go to Insert Function. We're in the Formulas tab, Insert Function. We're going to type in binom and hit go. So there's a bunch of different ones here. We're going to choose this one that's got range at the end. In my opinion, this is the easiest one to use. So we're going to stick with this one. And it's a newer version of the formula. This wasn't always in Excel, so we might as well use it to our advantage. All right, so trials again for the shooter example was 8 because we were taking 8 shots. So we just fill in that N value here. And the probability she hits the target was 70%, but we'll do it as a decimal, 0.7, 0.70, same thing. And the number of times we wanted her to hit the target was exactly 6 out of those 8 shots. So we just put a 6 in this box. We do not have to fill in the second box since it's only one X value. And that is our answer. Same thing we would get if we looked it up on the table of values or if you did it with the by hand formula. Okay. A quick reminder about rounding. Say you want your answer to 4 decimal places. You're going to go to your home tab. You're going to be clicked on the box that you want to round. And in that same spot where we formatted the cells, there's these arrows and decimals that allows you to show more or less decimal places. You're just going to click that until you see the number of decimal places that you prefer. And it's going to round it for you as you go, and it will not erase your formula. So say we want 4 decimal places. There we go. I can still see my formula up here in the formula bar and on my formula page, and it rounded it for me. Okay, let's try the dice example. So the dice example, we were rolling a single die 6 times. We want the probability that a 2 is rolled at least 4 times. So in this case, our success is trying to roll a 2. And it might feel like there's more than one possibility here because you can roll a bunch of other numbers as well. But we're going to boil it down into either you roll a 2 or you don't roll a 2. So all those other numbers are going to be kind of grouped into the second possibility. Either you roll a 2 or you roll anything but a 2. So they didn't tell us here in the scenario, but they're just assuming you know something about a regular die. And since we're trying to roll a 2, they're hoping that you can just figure out the probability of rolling a 2 without them telling you is 1 out of 6. 1 out of the 6 numbers are a 2. And so the probability of not rolling a 2 would be the other 5 out of 6 numbers, but we don't need that for Excel. The fact that we're rolling the die 6 times means our number of trials is 6. That's our number of times we're doing the experiment. And then this time it didn't say we want exactly 4 times, like the last one where it was exactly 6. It says at least 4 times. So remember the phrase at least means that's like our minimum, and we'd be okay with that number or anything higher. So at least 4 times means 4 or 5 or even all 6. And we stop at 6 because we're only doing 6 rolls. So this time when we do the binomial formula, let's go back to our formulas tab. Let's go into our insert function. We can use that Binom.DIST.RANGE again. It should be right here on your recently used list. So we'll just hit OK. So we're doing 6 rolls. The probability of getting a 2 is 1 out of 6. And you can type it in like a fraction. You'll see they kind of make the decimal version over here. The number of times we want to get a 2 are 4 or 5 or 6. So we can do them each separately and then add them all together. That would work. You could do the 4 and then go back into the formula and do 5, go back in and do 6, and then have Excel add them all together. But even quicker than that is, since we want to do 4 or 5 or 6, we'll just put our starting value here, which was 4, up to our ending value, which was 6. And it'll do 4, 5, 6. It'll stop at 6, and it'll add them all together for us. And this is our final answer. So it's very quick and easy. And then finally, the product example. We were checking for defective products. So even though it sounds funny, don't think of a success as something that is good to you. Just think of it as something that you're trying to find the probability of. So since we're trying to find defective products and make sure there aren't many of them, that would be our success. Even though it doesn't sound good, that's still what we're looking for here. So little p stands for the probability of finding a defective product. The chance that we find a defective product is 0.01, tells us that in the problem. So that's going to be our probability of success. Little q would be 0.99, so because p is like 1%, so q would be like 99%, but we do not need that in Excel. We do need the number of trials. Each time you're checking a product is a trial. You'll get like a yes or no, is it good or bad? So our 100 products are the number of trials. And how many of them do we want to find defective? No more than 1. So definitely 1 is involved. But this is kind of like the at least phrasing where it means something else. No more than 1. That means that's our maximum. We don't want any more than 1. We don't want 2 or 3 or any more than that. But we'd be okay with less than 1 as well. So don't forget that 0 is also a possibility here, not just 1. 1 would be okay. We'd be also happy if we don't find any defective products. So none is like 0 for successes. So when we go over in here and we do that formulas, insert function, find our Binom.DIST.RANGE one more time here. This time our number of trials is 100 for our 100 products. The chance of finding a defective product was 0.01. The number of those that we would like to see are no more than 1, so 0 or 1. So put this in numerical order. lowest to highest, we're going to start at 0 and we're going to stop at 1. So that's our range on this one, just 0 to 1. And it'll do each of those and add them together. And again, you could do them separately, just do 0 and then just do 1 and then have Excel add them. But this will do it automatically for you all in one shot. And there is our final answer. So hopefully that helps you with going through a little bit of how you can do binomial distributions and binomial probabilities in Excel pretty quickly and easily, I would think. It might be one of your favorite ways to do it. And then also how to utilize Excel to be your calculator and a little bit of shortcuts to finding the different things that you can find about a probability distribution, such as the mean, variance, and standard deviation. One last thing, you might be asked sometimes to interpret things. Obviously, the binomial stuff that we just found are probabilities. So these are the chance of each of these things happening. You can see the product example had the highest probability. The dice example is a very low probability. That should make sense to you. I mean, if you're only rolling the die 6 times, the chance that you're going to get the same number most of the times out of those 6 is pretty slim. So we have a very unusual probability here. It's very low. So those are just probabilities, chances. Over here, back from the first part of this, mean is the average that we expect. So with these possibilities, 1, 2, 3, 4, and these probabilities associated with them, we expect a 3 to come out on average. Now, a 4 happens more often, but since there's a possibility of 1s and 2s, that kind of balances the average out, and that's why we kind of meet here at 3 for the overall average. And then the variance doesn't mean much on its own, although it matches the standard deviation here. The standard deviation is kind of like we wouldn't be surprised if we were off by a little bit because these are probabilities. It doesn't always happen like we expect it to. And so we should have like a little bit of a wiggle room, a little bit of range for error. And that's what our standard deviation is. So we're just saying like most of the time you're going to pick the number 3 on average, give or take 1. So 4 comes out pretty often as well as 2. Like kind of put 3 in the middle, and if you were 1 away from that on either side, those are your most common outcomes. And that should make sense looking at these probabilities. Again, 1 is the least common outcome. It's got the lowest probability, and that doesn't happen quite as often as 2, 3, and 4 do. So hopefully that makes sense. And don't forget that you can check your formulas anytime by going into your formula tab and clicking on show formulas. So if you need to see kind of what you clicked on and what you typed in, double check your work here, how you built these formulas. If the formulas are getting cut off here a little bit, just widen up your column and you can see the things that you put into this Binom.DIST.RANGE formula to double check your work there. And make sure that you are not rounding by hand and retyping the numbers in because it will get rid of these formulas then. We want to still be able to see the formulas in here. Another keyboard shortcut for showing the formulas is hitting the control key and the tilde, the little Spanish squiggle that's next to the 1. That'll also toggle back and forth between your formula page on and off. It says that if you kind of hover over this, the little keyboard shortcut. So I hope that is helpful for all those purposes, and this will definitely be helpful for your Excel Lab 3 assignment. Check in with any questions. Have a good day, everyone.